Hi students, Mrs. Jenkins here, and there's just a few things I wanted to cover about the layers in the atmosphere. So let's first take a look at this graph here. This is showing us the thermal layers of the atmosphere. There's 4 distinct layers: troposphere, stratosphere, mesosphere, and thermosphere, and they're identifiable based on the temperature characteristics. In between each sphere we have a pause. So in between the troposphere and the stratosphere we have the tropopause, and you can see we have a stratopause here and the mesopause here. Well, this red line is showing us the change in temperature with height. So each layer has a distinct characteristic if the temperature increases or decreases with height. So here in the troposphere, where most of our weather occurs and where we're located at the surface, and as you may have experienced if you've ever gone on a hike on a mountain, our temperature actually decreases with height. When you enter the stratosphere, it increases. The mesosphere, it decreases again. And in the thermosphere, it increases again. And that is how we identify the different layers of the atmosphere based on those temperature characteristics. Now, but rather than having a distinct upper boundary, the atmosphere merely thins out as the molecules become less dense. So as you can see in this diagram, the air towards the surface is more dense. There's more molecules in the same amount of space, meaning the molecules are closer together. So we call that a higher density. They're more dense. And then as we increase in altitude, the molecules become less and less. The air thins out, as you may have experienced on a hike before as well. The higher altitude, the thinner the air, the harder to breathe. The air becomes less dense. So therefore, the lower latitudes have higher density than higher altitudes. The book actually has an interesting piece of information about how Olympic speed skaters actually glide further per stroke at higher altitudes due to the decrease in density, the thinner air, and may take up to 14 fewer strokes per lap in high altitude areas, which I thought that was kind of interesting. So that density in the air also correlates with pressure, which is the result of atmospheric mass. And pressure also decreases as we go up in altitude. As you can see in this graph, it's showing us how pressure decreases in altitude. In high and low pressure, and the density of the air plays a major role in weather systems, which we'll look at later in the course. Now, when you go back to this graph again, it also tells us what the pressure is. If you see over here, MB, that's referring to millibars, which is pressure. So towards the surface, you generally have a pressure of around 1,000 millibars. And then as you go up, it decreases. We have 100, 10, 1 millibar. So if atmospheric pressure is related to mass, then we can determine that there's less molecules as we go up. Less pressure, less density, less molecules as we increase in height. Now it's important to consider that when you're later this week, when we're doing the Columbia Space Shuttle assignment, you'll want to consider how the density of the air and how the molecules are different in each layer and how that may have impacted the space shuttle. Another interesting fact about the temperature related to density here is, as I already stated, there's more molecules towards the surface and there's less molecules as we increase in altitude. So the thermosphere has very few molecules. So when we measure temperature based on the speed of the molecules. So here at the surface, there's a lot of molecules. So the speed of the molecules is a pretty consistent way for us to feel hot or cold. So the faster those molecules are moving here at the surface, the warmer our temperature feels. The slower they're moving, the colder our temperature feels. But here, as we increase in altitude, and say we're up here in the thermosphere where there's hardly any molecules, it's hard to measure the temperature in a way that we can relate to hot and cold, because if you measure the movement of these molecules in the thermosphere, they may be moving super fast, so their temperature is recorded as really high, but since there's so few molecules, the temperature actually doesn't feel hot like we consider it. So if you were to stick your arm out of a rocket ship when you're in the thermosphere, the air would actually feel very cold because you're probably not even touching any of those molecules that are moving super fast because there's so few of them. So anyway, I thought that was a little bit of interesting information you might enjoy, but please let me know if there's any questions, and good luck.